Hi friends, we'll solve problem on work energy principle. See what is given. A collar of mass 1 kg is attached to a spring and slides without friction along a circular rod which lies in horizontal plane. The spring is undeformed when the collar is at B. Knowing that the collar is passing through the point D with a speed of 1.8 meters per second, determine the speed of collar when it passes through points C and B. Take K means stiffness of spring as 250 newtons per meter. R means radius of this circular disc which is 300 mm, and distance OA is given as 125 mm. Now motion of this collar as it is along the circular track. What is important in this problem? Collar moves, you can say, along the circular track. If it rotates like this and end of spring is connected at A, but this one moves in horizontal plane, this is important. That means when this collar slides along the circular track in horizontal plane, there is no displacement in vertical direction. Therefore, work done by weight is zero for any type of motion along this circular track. Reason is circular rod lies in horizontal plane. Then in work done, you will get work done only by spring forces. For that one, what information is given in problem? Knowing that the collar is passing through the point D with a speed of 1.8 meters per second. That means the velocity of collar at point D is given, number one. Again, what is given? Spring is undeformed when the collar is at B. That means when this collar is at B, this one is undeformed length of spring. As you know, radius OB is 300 mm, length OA, this distance OA is 125 mm, easily will get free length of spring equal to AB. We'll subtract OA distance from radius. Once we'll get undeformed length, when it passes through position C and position D, we'll find out what is the length of spring, and from that one we'll find out deformation. That means first step in solution of problem is what? To find out deformations at position C and at position D, because at position B deformation of spring is 0, as length of spring is undeformed length, or spring remains undeformed at position B. Therefore, undeformed length of spring at position B, that means length AB of spring, what will get is undeformed length, of spring, which is equal to, now AB length, if you want to find out, just see figure, AB length you want to find out, you know OB is radius, that is 300, OA is what, 125, therefore this is 300 minus 125 equal to 175 mm. Once we will get this undeformed length, now deformation at any other position, if you want to find out, we will find out what is the length of spring. For that one, when collar passes through point C, length of spring is AC. How will find out length AC? We will apply Pythagoras theorem. OA is 125, OC is radius, from that one length AC is possible. Therefore, length AC, applying Pythagoras theorem, it is equal to OA square plus OC square. OC is radius, OA length is given as 125, its square, plus OC means radius, this one radius is square. If you calculate using calculator, this length AC comes out to be 125 square plus 300 square. This length AC, if you find out using calculator, it is 325 mm. Now you are getting length AB, which is undeformed length, length AC, that is 325. Next length AD, if you find out this one, just see figure, length AD is equal to AO plus OD. AO is given as 125 mm and OD is radius, therefore this one comes out to be 125 plus 300, that means how much? 425 mm. Length AD is AO plus OD, 125 plus 300, that means this length is 425 mm. Again, what information is given in problem is velocity at point D is known, where velocity at point D is 1.8 meters per second. Next, what is known is mass of collar. Mass of collar is equal to 1 kg. Now, if you apply work energy principle from D to any other position, you want to find out velocity at C as well as velocity at B. Therefore, applying work energy principle, applying work energy principle from position D to C. If you apply now work energy principle, work done by weight is 0 because collar moves in horizontal plane. Work done by forces when collar moves from D to C equal to kinetic energy initial means at D minus kinetic energy at position C. Now in work done by forces, what is required? Deformation at position D and deformation at position C. To find out this deformation, XD if we'll find out, which is equal to, now deformation at position D, if you want to find out what is the length of spring at position D is 425 mm and free length of spring is 175 mm. That means this length comes out to be deformation at position D. This one is 250 mm. We'll substitute this value in meters as 0.25 meters. Similarly, deformation at position C if we'll find out, it is the length AC means 325 minus 125. This one comes out to be 200. 325 minus 125. This comes out to be 200 millimeters. Undeformed length is 175. Therefore, length is 150 millimeters. Now work done by forces, half K initial deformation means at D, XD square minus final deformation means at position C. Here will not get any work done by weight. Work done by weight is 0. Kinetic energy at position D equal, right, it is half m into Vd square minus half m into Vc square. Now we'll substitute here values of K, XD and XC. Value of K is given in problem as 250 newtons per meter. That means half K is 250. XD what we are getting is 250 mm. We'll write this deformation in meters, 0.25 square minus at point C it is 150 mm is 0.15 meters equal to mass is given as 1, therefore half into 1. Velocity at position D is given 1.8 minus half into 1 into Vc square. Unknown term is only one, that is nothing but Vc. Using calculator, if we find out this Vc, Vc comes out to be 3.64 meters per second. This is our first answer. Similarly, you have to find out velocity of collar as it passes through point B. For that one, we will apply work energy principle, WEP, from D to position B. Again similar equation will get half K initial deformation is what? Initial deformation means XD square, final position is B means XB square equal to kinetic energy final means half m. Velocity at final position is B means VB square and initial is what? Half m initial is point D. Now once you substitute your values, here k value is known, xd value is known, xb value is known, velocity at point D is known. Therefore, velocity at point B comes out to be Vb equal to some meters per second. If you find out this value comes out to be Vb equal to 4.344 meters per second. Thank you.